Hi, what's up? Can you hear me? You should be able to see me soon too, but can you hear me? Yeah, and now you should be able to see me as well. Okay, hold on. Now you should be able to see me as well. How you all doing today? What's up? What's up? What's up? Hey, Basit, Kumar, Gaurav, Deepu, Tanu. So good to see some familiar faces and some new ones. We are trying out some evening sessions from today. What's up? What's up? Hey, hey, hey. Yeah. Trying out something new. I'm great. How are you, Milendra? What's up? What's up? Hey, what happened? Did nobody take any of these? By the way, आवाज साफ आ रही है, right? मैं कुछ नया चीज ट्राई कर रहा हूँ. Just checking if you can hear me clearly, you can see me clearly, and all of that. Homework questions किसी ने देखे नहीं? थमा मजा नहीं आ रहा है क्या? We've done 2 sessions. There was some very interesting homework questions, but it's okay. We'll get to it right now. तो इस session में we'll start right away. Gary. Oh, Kumar Gaurav is Gary. I forget, bro. Kumar Gaurav, like who's Kumar Gaurav? There's that photo now. I remember. Okay, all right. Hey, Basit ji, actually, subah ko there were a lot of people, on leave, so we had to move his session out. That's why मैं भी यहाँ से कर रहा हूँ. Yeah, because tomorrow is Independence Day, so most people are on leave. So there was some last minute cancellation. Sorry about that, Abhinandan and Mr. Basit. Mir Basit ji. Mir Basit ji. ठीक है, let's get started. We're going to do CP, CV and calorimetry today. But before that, कुछ मैंने जो होमवर्क सवाल दिए थे वो let's start off with that. यार ये काफी इंटरेस्टिंग थे. It's surprising that you guys, didn't find time to do it, but it's okay. We'll just look at it right away. So what was this question? It says m mole of an ideal gas, m not n, okay, at 27 degrees Celsius expands isothermally and reversibly from a volume of y to 10y. Then the work done is. Now here's the 10-second way of doing it, right? अगर मैं इन दोनों को डिवाइड करूं तो या तो मुझे 10 आएगा या तो फिर 1, या फिर 1/10 आएगा, right? And in none of the options, in just one of the options you have this, which means that this must be the answer. You can't have y inside this, you can't have y/10y. Well, y/10y is technically is 10, sure. So it's either B or C. Yeah, that's the hacky way of doing it. ये दोनों नहीं है. That's the quick way of doing it. अगर आपको ध्यान से करना है तो ध्यान से भी हम लोग कर सकते हैं. ध्यान से करने वाला क्या सीन होगा? Do you guys want to help me out with this? How do you solve this question? 27 degrees Celsius यानी कि 300 Kelvin. Okay. रिवर्सिबली, अच्छा रिवर्सिबली मतलब कि MRT/ln V2/V1, ये था P डेल्टा V का इंटीग्रल. तो वर्क डन शुड बी इक्वल टू नेगेटिव ऑफ दिस, बट हमको निकालना क्या है? वर्क डन ही निकालना है, नेगेटिव ऑफ दिस. ठीक है, V2 था 10y, ये था, तो ठीक है. Okay, yeah, so we just directly substituted in here and this is the answer. C is the right answer. Quick answer, and this was this one. What about the next one? A bit of a recap of the last session, right? हम लोग क्या कर रहे हैं यहाँ पे? An ideal gas expands against a constant external pressure of 2 atmosphere from 20 liter to 40 liter and absorbs 10 kilojoule of heat from the surrounding. Okay. What's the change in internal energy of the system? Do you guys want to solve this one with me? I'll give you a minute to solve it. It's just been 3 minutes since we started the class. So, hey, we have some time. Do you guys want to try solving this one? Yeah? A lot of you on the chat. Hi, hello, kuch to bolo. Koshish karo. Starting point I'll give you. VF is 40 liters. VI is 20 liters. The final volume था 40 liter. Initial volume है 20 liter. Okay. Absorbs 10 kilojoule of heat. Absorbs यानी कि heat in. बैंक में पैसा आया. मतलब positive. Okay. And delta U. Okay. B. Tanu's gave me the answer. Amazing stuff, Tanu. Anybody else wants to corroborate her story? Somebody was talking about law just before this, and I don't know why that's on my head. I use words like anyway, कोई इसकी कहानी को 5948. Yes, absolutely. Good job. But how do you get there? Right? This is positive. During calculating internal energy, why we neglect other forms of energy? Mir Basit, that's a beautiful question. अभी हम लोग सिर्फ गैसेस की बात कर रहे हैं. मैंने लास्ट कपल ऑफ सेशन में भी आप शायद नहीं थे, बट हमने ये देखा था कि maybe you didn't watch live, maybe you watched it afterwards. The deal was that we said that okay, पहले सेशन में कि internal energy बहुत different types की होती है, right? And in a gas, we are only looking at work done, okay, for an ideal gas, and गर्मी की वजह से जो change होता है. Okay, we are looking at non-reacting stuff, and then in this session we're going to look at reacting gases. तो a quick brief thing, details में आप वहां पे देख लें क्यों बाकी ignore कर रहे हैं. Later on when we do electrochemistry, you'll see हम लोग सिर्फ electricity की बात कर रहे हैं, तो हम ये अलग-अलग चीज पढ़ रहे हैं ताकि together you can form a big picture. I understand that this will be a lot more relevant to you if you're doing engineering, but hey, even in biology, your body is basically a machine, right? It does a lot of things. So for us also, a lot of these things are useful. ठीक है. Anyway, answers. Kiran, where is Neha ma'am? I guess she's on leave, dude. सब लोग छुट्टी पे, सिर्फ मैं काम कर रहा हूँ. I'm kidding. Everybody is, celebrating Independence Day. And since I have the setup at home, so I'm just doing it from here. Anyway, so plus Q, heat under I 10, and then I put a negative sign over here. Why? Because work is equal to minus P delta V. Okay, so negative sign मैंने डाला और P जो है 2 डाला, pressure negative नहीं होता है, pressure तो positive, and then VF minus VI. Now the important thing is that some students do is or don't do is देखो ये दोनों को as it is add नहीं कर सकते. One is unit का है किलोजूल और दूसरे का unit है लीटर एटमॉस्फेयर. I've got to get them to the same unit. ये बहुत जरूरी है starting point. ठीक है. So I am multiplying this with 101.3. I'm multiplying this with 10 power 3. After that इसको subtract करते मिलता है 6000 के आसपास, which is this answer right here. If you don't do this unit conversion, बोला कि भाई ये तो आंसर मेरा कुछ है ही नहीं. What are you saying? 10 minus तो ये कहीं पे है ही नहीं कुछ. ठीक है. Any doubts on this question? Are you guys good on this? कोई doubt है तो पूछ लो, otherwise we'll go on to the next, the actual class. This is supposed to be homework, but it's all right. It's all right. We are all in a learning phase over here. Homework नहीं किया तो क्या हुआ? हम हैं. इस बार कर लेना यार. It's life is easier if you guys do homework. Yeah. कोई doubts है तो please पूछो. What did we end the last session with? We said that delta H equal to delta U plus delta of PV, delta of the whole thing. And then we said that, look boss, delta of this whole thing means this. If you remember from differentiation, यही same चीज होती है, right? If you say D of PV is equal to P dV plus V dP. Mrinal ने आपको पढ़ाया होगा, right? When he was doing maths, the maths part that's required in physics, right? Mrinal sir, Mrinal ji, sure. Okay. This is the same thing I'm using, but I'm using the term delta. But at constant pressure, delta P is 0. Hence, we derive this equation. That's all you need for this session right now. So let's get started. Let's get started. Everyone's okay? No one's saying anything on chat, so I'm just checking. I'm hoping you're all listening and everyone's just good with everything that's being said right now. Okay, cool. So what are we going to do today? We're going to talk about enthalpy in a little bit more detail. हम लोग extensive intensive properties पिछले session में already कर चुके हैं, ठीक है? Heat capacity, that's the new thing. CP, CV are different forms of heat capacity, okay? And then that's what we're going to talk about next. And lastly, measurement of delta U and delta H on calorimetry. All right, sweet. Let's get started. Hello, hello, hello. Okay, hey Kiran, what's up? Okay, cool. Just checking chats. So, ये मैंने जो last session में बोला था, same चीज यहाँ पे लिखी है कि delta H is equal to U, delta U is equal to QV when the volume is constant, right? But अगर नहीं है, then you need to account for this P delta V. But here's the thing, right? In some reactions, when reactions happen, what happens? Number of moles of gases could change. Now this is interesting. Now we are switching gears. अभी तक मैंने last session बोला तो उससे पहले भी बोला था कि look, ideal gas, non-reacting mixtures. In fact, जब बसीत ने भी मेरे से पूछा, बसीत, am I pronouncing your name correctly? Basit, how do I pronounce it? Is it like A or E? Like Basit, where's the stress? Or shall I just call you Mir? That's a much cooler name. Like Mir Publications, who from Russia, right? They have these really cool books like Loni, SL Loni and all of that for JE Advanced and Iridoff and all that. Anyway, I digress. So, यहाँ पे अजीब सा फॉर्मूला लिखा है delta NGRT. What does this have to do with anything? देखिए, now reactions are happening. Okay, so take it with a pinch of salt कि अगर temperature constant है, तो reactions, most reactions we assume happen at constant temperature. We assume that and at constant pressure. Now, अगर ये दोनों constant है, the only way volume would change अगर number of moles of gas changes. Now, why would a number of moles of gas change? Maybe reactants के जो gases थे और products में जो number of moles है gases के वो अलग है. इसीलिए this would happen. I'll show you with an example, right? So what is delta Ng? It's the number of moles of gaseous products minus the number of moles of gaseous reactants. You'll notice that solids और liquids के बारे में कुछ नहीं लिखा है यहाँ पे. क्यों? क्योंकि solids और liquids, well, nothing really happens to them in terms of PV work. Mir asked me a brilliant question and I'm using that to build everything after this. Why do you only talk about, you don't talk about the other forms of energy? I'm only concerned about work done, okay, and heat. Both of these things are the only thing I'm talking about right now, okay. All right, great, awesome. So for an example, let's take a look at this. Now this will be all clear right now. N2 plus 3H2 gives you 2NH3. What is delta Ng here? 2 minus 4, right? So it should be negative 2. As simple as that. That's it, that's it, that's it. Any doubts here? We good so far? Yeah? It may seem like मैं थोड़ा जल्दी बोल रहा हूँ. I'm in no hurry. I have all the time in the world. The reason I'm going a little quick is I don't want to bore you, okay? But if there's anything that you want me to repeat, please push it, okay? No questions are not asked. Mir is best, ठीक है? One syllable, awesome. ठीक है? So what's the relationship between delta H and delta U? This is what you get. Now you'll see that this is the same as this delta U plus P डेल्टा V, यही चीज है, बस मैंने लिखा है कि P डेल्टा V को as डेल्टा NG RT. ओके, that's it, that's the only thing I've done, that's the only mathematical jugglery that I've used. उसके अलावा तो सब सेम ही है. ठीक है, cool. Delta H is heat at constant P, a quick reminder. Delta U is heat change at constant V. ये मैंने पहले सेशन के एंड में भी यही चीज बताई थी. अगर ये चीज याद नहीं है about this one, look it up at the end of the first session, L1 of thermodynamics, right? Okay. Now, is there a possibility, or that thing bubble should have been on top of my head? It's a different corner. Anyway, can delta H ever be equal to delta U? Yeah, अगर delta NG somehow zero हो जाए. अगर delta NG zero होगा, उसका क्या मतलब है? उसका ये मतलब हो सकता है कि अरे इस रिएक्शन में तो गैसेस है ही नहीं, मतलब कि उस रिएक्शन में सिर्फ सॉलिड्स और लिक्विड्स हैं. या दैट्स वन केस, राइट, लाइक दिस. यहाँ पे है HCl और NaOH, बहुत ही एक्सोथर्मिक रिएक्शन. एक्सोथर्मिक, अच्छा मैंने थोड़ी आई जंप द गन. मे बी ऑलरेडी नो. डू यू नो व्हाट दिस टर्म मींस? एक्सोथर्मिक का क्या मतलब है, आपको मालूम है? याद आ रहा है क्या? डज एनीबॉडी नो? हे दीपान्विता, दैट्स ऑसम, दैट्स ग्रेट. Good to see you guys here. I was not sure if the 7 o'clock time would suit everybody, but most of you said that it works for you, so I've gone ahead and done this. Okay, exothermic का मतलब मालूम है आप लोगों को? Yeah, it means when heat is released. ये जब रिएक्शन होता है तो ये पानी बिल्कुल गर्म हो जाता है, बहुत गर्म हो जाता है. HCl NOH, right? We'll look at this in this session and in the next session in detail. Exactly. खैर, जो भी होता है इसमें gaseous compounds है ही नहीं, मतलब डेल्टा NG 0 तो डेल्टा H इज इक्वल टू डेल्टा U. दूसरा केस ये भी हो सकता है कि देखिए, द नंबर ऑफ मोल्स ऑफ gaseous reactants is equal to the number of moles of gaseous products, like this chap right here, right? Look at that, 2 moles of gas and 2 moles of gas, they cancel out. In both of these cases delta H is equal to delta U. आप लोग ध्यान से सुन रहे हैं ना, इस पे सवाल आने वाले हैं बहुत जल्दी मतलब कि लिटरली नेक्स्ट स्लाइड में. तो डेल्टा NG इक्वल टू 0 मतलब इक्वल है. अगर डेल्टा NG इज नेगेटिव देन डेल्टा H डेल्टा U से थोड़ा कम हो जाएगा, और डेल्टा NG इज पॉजिटिव तो डेल्टा H इज लिटिल ग्रेटर देन डेल्टा U. लिटिल बिट ऑफ मैथ्स. चलो एक सवाल देखते हैं. ओके, हे शालिनी, ऑसम, परफेक्ट. हे प्रमोद, व्हाट्स अप? आई डोंट थिंक यू सीन मी बिफोर. मेधा, एब्सोल्युटली राइट. Apologies that I missed your comments. I've got a huge screen in front of me, so just trying to get used to it. Okay, great. Assume each of the following reactions to be carried out in an open container. Yes, Meerji, absolutely. Assume each of the following reactions to be carried out in an open container. Open container, this is a beautiful way of saying that pressure is constant, which is atmospheric pressure. I absolutely love these guys who make these questions. They're so intelligent. एक शब्द सवाल का matters a lot. Okay, for which reaction will delta H be equal to delta U? जब तक मैं अपनी कहानी बोल रहा था, my admiration for my good friends who are making these questions at NEET in 2006. Wow, that was the year that मैंने एग्जाम दिया था. Well, NEET नहीं दिया था, JEE दिया था, but everybody seems to agree with B. Shalini, Abhinandan, Deepanvita, Deepu, and Tanu making it a good 5. Yes, absolutely. B is the right answer. You want to look at the other two just to be sure. यहाँ पे 2 हैं, यहाँ पे 3 हैं, यहाँ पे कितने हैं? 3 हैं, यहाँ पे 2 हैं. इसको हम लोग कंसिडर नहीं करेंगे, सॉलिड है. और यहाँ पे कितने? 1 और 1 और 1. मैंने लिख भी दिया क्योंकि कुछ स्टूडेंट्स बाद भी देखेंगे लाइव के बाद में भी, तो उनको भी तो दे शुडंट फील लेफ्ट आउट, तो इसलिए मैं लिख के दे दिया कि भाई क्लियरली इसमें इक्वल है. ठीक है, ऑसम. मीर एंड तनु एंड दीपू 100% राइट. यू आर ऑल करेक्ट. गुड जॉब एवरीबॉडी. सब लोग बातें अच्छी तरह सुन रहे हैं, बहुत अच्छी बात है. एक और सवाल. फॉर दिस रिएक्शन C2H5OH plus 3O2 gives 2CO2 plus 3H2O. Which one is true? सेम आइडिया हमको यूज करना है. कौन सा आइडिया मैं बताऊं या आप लोग आंसर बताओगे? ट्राई करो. I'll give you like 30 seconds to do this. That's more than enough time I feel. ट्राई करो इसको. इस वाले के भी बी बोल रहे, पुराने वाले के भी. अच्छा, इस वाला शालिनी is saying A. Great. I love the speed on these questions. The thing is, देखिए ये भी नीट का सवाल है, और ये सवाल ऐसे हैं जो इतनी जल्दी हो सकते हैं जितनी जल्दी आप लोग कर रहे हैं. शालिनी, तनु, अभिनंदन, एब्सोल्युटली अमेजिंग. मीर एंड दीपू, मेधा, दीपान्विता, यू गाइस आर सो अमेजिंग. लुक्स लाइक 7 बजे सब लोग ज्यादा चार्ज अप होते हैं एज कंपेयर टू 4 बजे. 4 बजे तो खाने के बाद वाला टाइम होता है, सब लोग बहुत नींद में रहते हैं. आप अभी यू गाइस आर गुड. दैट्स ग्रेट, दैट्स ग्रेट. तो ठीक है, लुक्स लाइक ए इट इज. ए कैसे आया? डेल्टा H इज डेल्टा U प्लस डेल्टा NG/RT. नंबर ऑफ मोल्स कितने हैं? यहाँ पे हो गए 2, ये तो लिक्विड है, इसको हटा देते हैं. और यहाँ पे हो गए 3, ये भी लिक्विड है, इसको हटा देते हैं. तो 2 - 3, 2 - 3 मतलब कि डेल्टा NG इज -1. अब ये लिख लिया, तो डेल्टा H इक्वल टू डेल्टा U माइनस RT, which is this option right here. ग्रेट जॉब एवरीबॉडी, बढ़िया बढ़िया। एक और सवाल, कैलकुलेट थर्मोडायनेमिक्स गोइंग टू बी अमेजिंग एंड फास्ट पेस, लाइक बहुत सारे सवाल। इनफैक्ट ऑर्गेनिक वीडियो में शुरू करने वाला हूं, उसमें भी ऐसे ही होने वाला है। स्टे ट्यून्ड। कैलकुलेट द चेंज इन इंटरनल एनर्जी इफ डेल्टा एच इक्वल टू -92.2 किलोजूल, P इक्वल टू 40 एटमॉस्फेयर एंड डेल्टा V इज -1 लीटर। ध्यान रखिएगा इस सवाल में, ध्यान रखिएगा, ये ऑप्शंस एम्स का सवाल है, मुश्किल नहीं है, बट ऑप्शंस ऐसे हैं कि दे कैन ट्रैप यू। ठीक है, दैट्स अ स्मॉल हिंट। यार ये लगता है आप लोग सवाल देखा हुआ, इतनी जल्दी कर लिया यार, यू गाइस आर ब्रिलियंट। नहीं देखा हो तब भी बढ़िया है, अगर अभी किया तब भी बढ़िया है। अभिनंदन एंड तनु गिविंग अ रन फॉर एवरीवन्स मनी, इतनी जल्दी सवाल कर रहे हैं, बहुत सही है। गिव मी अ सेकंड। Yeah, I have a glass now, much easier than that huge bottle that I used to carry. Mir is saying A, okay. हाँ देखिए, मैंने बोला था कि यहाँ पे ट्रैप है थोड़ी छोटी सी, और इनफैक्ट जब मैंने भी पहली बार सॉल्व किया था तो मुझे लगा यार ये तो आंसर ठीक है, बट लाइक हे ध्यान से करो, ध्यान से करो। मैंने यहाँ पे एक चीज सर्कल की है, ओके। सो देयर आर टू थिंग्स टू बी केयरफुल अबाउट। देखो डेल्टा एच नेगेटिव है, डेल्टा वी भी नेगेटिव है, और इक्वेशन क्या है, एक और सॉर्ट ऑफ छोटी सी चीज है, 1 लीटर एटमॉस्फेयर इक्वल टू 101.3। तो ये तीन चीजें हमको ध्यान में रखनी है। आई सी दैट द स्पीड हैज स्लोड डाउन, जैसे ही सवाल थोड़ा सा ऊपर गया सब लोग थोड़ा बहुत टाइम ले रहे हैं करने के लिए। इट्स ऑलराइट, टेक योर टाइम, मैं धीरे धीरे तब तक एक्सप्लेन करता हूं, ठीक है प्लीज। बट इफ यू आर ट्राइंग इट आउट, गिव मी द आंसर इन द चैट, ओके। सो डेल्टा एच इक्वल टू डेल्टा यू प्लस पी डेल्टा वी। नाउ notice that I've switched gears. I'm not doing the whole delta NGRT anymore. So the main thing in NEET or in any exam is to figure out भाई कौन सा इक्वेशन लगाना है, राइट? और वो इक्वेशन कहां तक वैलिड है, कहां तक वैलिड नहीं है। अगर आप इसमें इफ यू ट्राई डूइंग दिस होल थिंग ऑफ डेल्टा यू प्लस डेल्टा NGRT, कि भाई नंबर ऑफ मोल्स कहां है राइट राइट। सो यू गॉट टू बी केयरफुल एज टू व्हाट इक्वेशन टू अप्लाई, ठीक है। ये वाला नहीं होगा यहाँ पे, इसलिए I've used this equation. Deepu is also saying B. I've got Deepu, I've got Tanu, I've got Abhinandan saying B, and me is saying A. Take your time, guys. Everybody else, while I explain, जवाब दीजिए मुझे. So now I've got to find out delta U. You'll notice that I've written some sort of an expression. Let me explain what I wrote. एक तो ये negative 92.2 है, ठीक है. This small this thing is a negative sign, ठीक है. और I have to make sure कि ये किलो जूल है, मतलब into 10 power 3. दूसरी चीज 40 है प्रेशर, डेल्टा बी इज -1, ये प्लस साइन एज इट इज रखा, ओके। बट डेल्टा यू इक्वल टू डेल्टा एच माइनस पी डेल्टा वी। ध्यान से करने वाली चीज है, ये दोनों नेगेटिव साइन मैंने लेके बाहर कर दिए। अब मुझे ये तरीका आसान लगा तो मैंने इसे कर लिया, ये जल्दी मुझे लगा तो आई वाज श्योर कि अच्छा इट्स 92 - 4 मतलब 82 होगा, अब सॉरी 88 होगा, मैंने मार्क कर दिया। बट 88 प्लस या माइनस है, बी केयरफुल अबाउट दैट। Now, Mir, are you okay? Do you see why it was B? I know आपको 42 कैसे आया। I think आपने गलती से इसमें नंबर वाला ठीक से नहीं किया होगा, तो इसलिए 40 आपने हटा दिया, 92 से 40 हटा दिया तो नहीं, उससे 42 हो गया क्या, उससे 52 हो जाएगा, ठीक है, नो प्रॉब्लम, इट्स ओके। बट मीर, आर यू ऑल राइट? डिड यू गेट दिस क्वेश्चन? एवरीबॉडी एल्स ऑन द चैट, यू गाइज आर ऑल राइट? शैल आई गो अहेड? ये वाला थोड़ा सा ध्यान से करने वाली चीज, आई एम नॉट सेइंग दिस इज मुश्किल है। Thermodynamics deleted है Manoj? I don't think so. And also I think there was what you mean to say states of matter is deleted, but it doesn't matter, no, deleted या undeleted। आपने वो शॉट नहीं देखा क्या अंकिता का? जब तक एनटीए नहीं बोलता we'll keep studying bro। we've got to, right? एनसीईआरटी लीड कर रहे हो तो क्या हुआ? our focus is एनटीए, the examining agency, right? Okay, it's all right, यार। maybe maybe he thinks you're doing gases, it's okay, it's okay, everybody makes a little bit of a error here and there, no problem Manoj। either way I think it's a good thing to study this because thermodynamics काफी बड़ा है, it's there in physics and in chemistry, और दोनों जगह में आसान मार्क्स आते हैं अगर इसको पढ़ेंगे, ठीक है। that's one reason for studying it. Second reason is कि thermodynamics is needed to do equilibrium and also needed to do electrochemistry, so काफी important chapter है, और thermodynamics is linked to gaseous states, so it matters well। खैर anyway, चलो let's move on to heat capacity, which is what was on the thumbnail today, right? What is heat capacity? Now, theoretically, I've got some water here, same amount of water, I'm raising its temperature by 35 to 36 degrees Celsius. And that's about it. It's the amount of heat required to raise the temperature of whatever you've got by 1 degree Celsius. Okay, that's all. That's what heat capacity is. Now, why does the word heat capacity kya matlab hai? I could have just said heat. Why heat capacity? You got this beautiful thing happening here, and this sand right here, and there's water right next to that. You can see that गर्मी में sand बहुत ज्यादा गर्म होता है और पानी इतना गर्म नहीं होता है. Yeah, that's what this sort of animation is trying to tell you. पानी का temperature say theoretically gone to 27, और sand बहुत गर्म हो गया to 35. Now obviously this is an initial thing. With time they should be the same temperature. Theoretically वो sun सर के ऊपर है, but sand ज्यादा गर्मी ले लेता है, उसका temperature ज्यादा से बढ़ जाता है. What does that mean? Let's understand that. अगर दो अलग अलग substances हैं तो उनका temperature अलग अलग तरीके से बदलेगा. Okay, so sand is raising its temperature, whereas water is keeping the heat in without raising its temperature. मैंने लास्ट कपल ऑफ सेशन में बोला था कि हीट और टेम्परेचर आर वेरी डिफरेंट, और स्टूडेंट ने किसी ने पूछा भी था. दिस इज द बेस्ट वे टू अंडरस्टैंड इट. देखो, पानी में कुछ एक बहुत ही स्पेशल चीज है कि इट हैज अ वेरी वेरी हाई हीट कैपेसिटी, यानी कि वो गर्मी लेता रहता है पर उसका टेम्परेचर नहीं बढ़ता है. ओके, दैट्स अ वेरी इंटरेस्टिंग थिंग. तो इसीलिए ठंडा करने के लिए रूम में आप थोड़ा पानी छिड़क दो, फैन चला लो, तो बहुत जल्दी ही ठंडा हो जाता है रूम, क्योंकि वो पानी बहुत हीट अब्सॉर्ब कर लेता है. ठीक है, तो द आइडिया ऑफ हीट कैपेसिटी इज द अमाउंट ऑफ हीट that something requires to raise its temperature by 1 degree Celsius, and changes when you change the substance. Okay, and water has a high heat capacity. क्यों? क्योंकि बहुत ज्यादा हीट लगी to raise the temperature just by a little amount. Is this idea okay? यहाँ पे जो थोड़ा सा टेक्स्ट लिखा है, out of water and sand, इसकी हीट कैपेसिटी इज ग्रेटर. वाटर की हीट कैपेसिटी इज ग्रेटर देन दैट ऑफ सैंड. मेरे सर के ऊपर लिखा है. इज दिस क्लियर गाइस? बहुत जरूरी आइडिया है, बहुत बेसिक आइडिया, बट बहुत जरूरी है. इज दिस ऑल राइट? आर यू गाइस ओके व्हेन यू अंडरस्टैंड दिस? There's a bit of a lag between what I say and what comes over here. So let's just wait for a couple of, like 20-30 seconds for you to give me a response on this. I'll just move on to the next one. हाँ ना बोल दो. Okay, Milinder, great. So yeah, because energy required to raise temperature is high. Already mentioned that. Okay, so what happens? अगर मैं ज्यादा heat दूं तो temperature ज्यादा बढ़ेगा. This is obvious, right? This blue flame, usually a blue flame is a higher temperature. Say like, let's say theoretically this is 1200 degrees Celsius. Theoretically, oops, ये cover हो गया. Theoretically say this is 800 degrees Celsius. Theoretically ऐसे बोल रहा हूँ, कुछ नंबर दे रहा हूँ. तो अगर ज्यादा heat same time के लिए अगर ज्यादा heat दूं तो पानी का इस वाले का temperature ज्यादा बढ़ जाएगा. ठीक है? Okay. That's very easy to understand. Okay, Medha, Milendra, Deepanwit, thanks for that. और अगर मैंने कम मास लिया तब भी उसका टेम्परेचर ज्यादा बढ़ेगा. तो this amount of heat that increases, it depends on the mass. तो ये एक्सटेंसिव प्रॉपर्टी होनी चाहिए, है ना? एक्सटेंसिव, क्योंकि एक्सटेंसिव मतलब कि it depends on the mass. Okay. And the last point is, let me now make it a little bit more formal, right? The total amount of heat capacity is the heat required to raise the temperature of the system by 1 degree Celsius under given process. ठीक है? Now, this heat is proportional to temperature. So I can say that this heat is equal to C times delta T. Now, C was the heat capacity, right? Extensive and a path function. Path function कैसे है? Path. Oh, you remember from the first and the second session? Path का क्या मतलब था? कि distance or displacement. Distance is a path function, displacement. This is path, and let me use a different color here to just reiterate my point. This is state, right? So what I'm saying now here is कि ये path function है, यानी कि अगर मैं constant volume पे करूं तो कुछ और हो सकता है, constant pressure पे करूं तो कुछ और हो सकता है. You remember? ये सब अलग अलग paths है, reversible, irreversible, etc., etc. They were all different paths. Yeah, याद आ रहा है? अगर ये थियरी याद नहीं आ रही है तो एक बार फिर से सेकंड सेशन देख लेना वो वाला पार्ट में. ठीक है? Awesome, Mir. H is CT or U CT. Yeah, that's interesting. Well, I'll get to that. Both are C, but one is CV, other is CP. Mir. Lord Vader, what up? Oh my God, Discord people. This is your name here too as well. सही है भाई. ठीक है, मेटा की क्लास है 8:45. Vader, you want to do meta, right? That's at 8:45. But sure. Awesome, good to see you. Now, that was an extensive property, but the moment I divide heat capacity by the number of moles, it becomes an intensive property, right? So heat required to raise the temperature of 1 mole of a substance by 1 degree Celsius. Now, this is always going to be a fixed value for a particular substance. Hence, this is intensive, okay? So, yeah. Now, this one right here, I can go ahead and say that is simply going to be, but it's still a path function, okay? It doesn't change, it's not a state function. It could still change when I fix this or I fix this. This is the next idea I'm going to talk about quickly. I'm sure आपको ये idea already, अगर आप NCERT पढ़ चुके हो, अगर नहीं पढ़े हो तो ये part थोड़ा सा लगेगा कि सर के ऊपर जा रहा है, but my suggestion is that focus on the numericals. ये थोड़ा सा abstract है, okay? But the idea of water में समझना आसान था, but ये idea कि अच्छा CM intensive क्यों है is very straightforward, right? I'm dividing two extensive properties. ये भी हमने पिछले सेशन में कवर किया था, अगर याद नहीं आ रहा है तो दो extensive properties को divide करो तो you get an intensive property. So this is intensive, but it's still path dependent, okay? All right. So what are the different paths? I can say that, okay, now Q is going to be N times Cm times delta T. Remember, purana wala tha Ct times delta T, and this was extensive. This guy here is this, and this is intensive. Okay. All right, great, Tanu. Thanks for the, thumbs up. Okay. So I said that there are two different paths that we're going to look at specifically. What are they? First one is, अगर मैं constant volume पे कोई process करता हूँ या constant pressure पे, क्यों? देखो यार, this is like the cooker example, which is most reactions, in an industry are carried around in a closed lid. अगर बंद जगह हो रहा है, then that's like a cooker. Or the other reactions are happening open to the atmosphere, right? If they're open to the atmosphere, then P is this atmospheric pressure. So this is constant pressure and this is constant volume. इसलिए हम लोग इन दोनों को specifically पढ़ रहे हैं, ठीक है? So, okay, let's look at constant volume पहले. मुझे लगता है हम लोग again first session में जो बोला था उसी चीज को हम लोग थोड़ा और बढ़ाते जा रहे हैं. du is dq plus dw, और मैंने ये बताया ना आपको कि क्यों when you do constant volume then this is zero, hence du is equal to dqv, और उस समय मैंने बोला था कि delta u is equal to qv. अब मैंने बस यहाँ पे छोटा d लगा दिया, छोटा d मतलब infinitesimally small. Okay, great. So du is ncv delta t. Now there's also a small m over here. Why? Because I'm talking about constant volume. I'm also talking about molar heat capacity. Okay, that's why there's a v comma m. In your boards, if you're writing something, you're gonna have to write the full thing. V comma m लिखना पड़ेगा. Otherwise, for it, everywhere else you can just write cv. It's cool. Okay. Look at the next one. At constant pressure, I'm going to say very confidently that dH is equal to dqp. That was the definition of enthalpy. हमने enthalpy define इसलिए किया. Oh, heat at constant pressure means a new definition because reactions happen at constant pressure. Okay, open to the atmosphere and all of that. Okay, dH now is going to be equal to ncp delta T. This is the second path, so to speak. What is the first path? Just a quick reminder was when we said that, oh, delta V equal to 0. And there we had that du is equal to ncvm delta T. And this guy here is ncpm. Any doubt so far? This looks like a maths class, right? Derivation. Okay. I can also define another thing called specific heat capacity. Just like there's molar heat capacity. Now I'll say instead of 1 mole, let's take 1 kilogram. Specific, matlab 1 kilogram. Most things, specific volume is also, won't talk about that. Ignore that, I just said that. But yeah, that's just volume per meter cube. मैंने इसके बात की थी, by the way, specific density, specific volume and all that. Anyway, care. Whenever you say specific something, is usually divided by 1 kilogram of stuff. That was not correct. V by meter cube nahi tha. That was meter cube by kilogram. Sorry, yeah. That was specific volume. I did this in gaseous state, by the way, when I told you about Andrews isotherm and all of those other things. Care. Let's move back to this. Specific heat capacity is the heat required to raise the temperature of 1 gram of substance by 1 degree Celsius. Okay, not 1 kilogram, 1 gram. Okay, sweet. This is the definition and here we go. Shall we do numericals? I think बहुत ज़्यादा theory हो गई. One last thing to summarize everything and then we'll quickly do numericals. Now, for an ideal gas, right, can we relate Cp and Cv? I've told you that there are two different paths, but there's a way to relate them. Just like I said that, oh, delta H can be, something in terms of Cp, this guy can something in terms of Cv, and this can be written in some terms of R. Now you notice that very conveniently, I've gotten rid of this delta Ng and I'm back to Nr delta T. Yeah, you'll notice that. Because I'm talking about an ideal gas. Remember, मेरे सर के just weirdly इधर है. Okay? I know. Switching a lot of gears and thermo is a little weird like that. Okay, remember, now I'm not talking about necessarily just a reaction happening. A reaction may happen, a reaction may not happen. I'm just trying to form a relationship between Cp and Cv. So I'm assuming everything is, awesome. There's a song, right? Everything is awesome from that Lego movie. Everything is awesome. Anyway, it's a funny song. Sorry. This right here, okay, I'm talking about an ideal gas, and I'm talking about different parts. Cp at constant pressure, constant volume, and maybe some work can also get done. These are the only three things that could happen to a gas. Okay, I carry out something at constant pressure, something volume, and this thing. So now you know what's going to happen. Are you already writing this? जब तुम्हें कहानी बता रहा था अभिनंदन और दीपान्विता ने already लिख दिया. That's great. You students are amazing, right? Because what you're doing by giving me that is you're helping me. You're giving me feedback. You're understanding what's going on. While I'm giving you all the theory and the insights, the maths is very direct, right? Well, let's do the math. Math तो काफी straightforward है. As your friends have pointed out, Cp is Cv plus R and Cp minus Cv is equal to R. मतलब Cp is always greater than Cv. R की वैल्यू आपको मालूम ही है. In calories, it's 2 approximately, right? Oh, this should be 1 over here. Mayer's formula. Meer, look at that. Meer on fire. R can also be this. It can also be 1 by 12 or 0.0821 liter atmosphere per mole Kelvin in brackets. I can also write this as 25 by 3. I've done questions in states of matter where we use both of this. Again, reminder, Cp is always greater than Cv. Okay. If you remember this, I can just quickly in like what time is it? It's half an hour. अरे बहुत time है life में, बहुत time है. ठीक है. Let me just quickly tell you this. How do you remember this? If you forget it, देखो. Here is a movable piston. मतलब ऊपर नीचे जा सकता है. Here is a fixed piston. मतलब कि this is delta V equal to 0. This is delta P equal to 0. What is the pressure? It is atmospheric pressure. Now, think about it like this. If I heat both of these things, ये बहुत ही simple way है इसको समझने का. Then, in this case, all the heat goes in raising the temperature. Okay, all heat. Let me write properly. क्यों? All heat delta T. In this, heat goes into delta T and work done. What work? Expansion work. इसीलिए ये वाला heat will be greater than ये वाला heat. Khatam. You see how the path at constant pressure requires you to do more work, and there is also heat, like hence heat as compared to Cv. ये समझ में आया? Meer is giving me another formula. That's awesome. Abhinandan is giving me something as well. Okay, but did you understand this? कि क्यों Cp is equal to Cv? Math से तो समझ गए आप लोग. But did you understand with this explanation? मेरे हिसाब से ये explanation ज्यादा जरूरी है क्योंकि जल्दी जल्दी में आदमी भूल सकता है, मैथ्स भी भूल सकता है. बट वंस यू इंटरनलाइज एक बार ये डायग्राम ड्रॉ कर लोगे ना, यू विल नेवर फॉरगेट इट. ओके, चलो सवाल करते हैं. बहुत थियरी हो गई. A student must use, great, Meda and Deepanvita, thank you for the feedback. The student must use 225 ml of hot water in a lab procedure. Calculate the amount of heat required to raise the temperature of 225 ml of water from 20 degrees Celsius to 100 degrees Celsius. Or specific heat capacity of water is given to be 4.184 joule per gram per degree Celsius. I can also write this as 4.2 or something, and I can make it kilojoule per kg degree Celsius, or I can make it per Kelvin. Per Kelvin और per degree Celsius सेम है. Per Fahrenheit अलग जाता है, नीट में नहीं होता है, तो skip that. But आपको ये सेम चीज per Kelvin में भी लिखी जा, you can replace it with Kelvin. It still works. If I replace this with kilojoule and kilogram, that also works. Just some other variations of everything you could see. कोई ये सवाल ट्राई कर रहा है? मुश्किल है क्या? TF और TI दिया हुआ है, मैंने यहां पे लिख दिया है. आगे थोड़ा आप ट्राई करिए. What equation will you use? Just this. Q equal to mc delta T. Please try it out. I'm just looking at your comments. Cp minus Cv equal to R by N2. N2 क्या है? अभिनंदन? Meer. Yeah, absolutely. So, Meer, you're right. इसलिए मैंने Cp, M लिखा था, right? मतलब मोलर हीट कैपेसिटी की हम लोग बात कर रहे थे. थैंक्स फॉर पॉइंटिंग इट आउट. मैं जब भी Cp और Cv बोल रहा हूं, मैं हमेशा एक मोल की बात कर रहा हूं. बट थैंक्स फॉर पॉइंटिंग इट आउट. बिकॉज Cp is intensive. Sorry, Cp is extensive and a path function. But CPM, that's intensive. Yeah. So it doesn't depend on amount of stuff. So CP minus CV, when you take 1 mole of stuff, yeah, great man. I like जितनी बारीकी से आप लोग चीजें कर रहे हो, me and Abhinandan and everybody else. How is this question going? Are you guys trying it out? मुश्किल लग रहा है, आसान लग रहा है? How is it going? You want me to give you a little bit more of a, you know, थोड़ा और मैं आपको help करूं? Tanu's saying A. Okay, awesome. A for awesome. 3 times Tanu ने A बोला. Must be right. What do the rest of you think? So the mass is, well, mass तो नहीं दिया है. मैंने mass 225 क्यों लिख दिया भाई? Mass तो दिया ही नहीं है. हाँ, पानी की डेंसिटी क्या होती है दोस्तों? पानी की डेंसिटी is 1 gram per ml, right? So 225 ml, this is going to be equal to 225 gram. Just a small leap of faith, which is correct. C सब्स्टिट्यूट किया है, डेल्टा टी सब्स्टिट्यूट किया है, बस खत्म. क्या हुआ? बाकी लोग क्यों अटक गए? ए संचिता, awesome, good to see you here, good to see you here. Yeah, trying this time out to see if works for you students. So ठीक है, बट ये सवाल डुएबल है. आई थिंक इसका मैथ में सीम अ लिटिल कॉम्प्लिकेटेड. नो, तो दीपान्विता is also saying it. Let me tell you how to do this quickly. Just do this 225 into 80 को आप लिखो 4/5 into 100, ठीक है. एंड ये C को क्या लिखोगे? 4.2. अब ये लिखने से क्या होता है? ये हो जाएगा, ये 20 हो गया, ठीक है. सो नाउ नहीं, दैट आई शुड नॉट हैव डन, दैट मेक्स नो सेंस. तो सेम चीज फिर से हो जाता है. लेट्स कीप दिस एज 100, लेट्स कीप इट एज 5. अगर ऐसे लिखने से क्या होता है? डज इट हेल्प, डज इट नॉट हेल्प? तो 4 into 4 16, 16 into 2 is 32, 32/5. नहीं, this doesn't help. I think in this case यार मैथ्स ही करना ज्यादा आसान है. 4 into 8 into 2 मतलब 32 into 2, so 60 के आसपास. नो दैट्स रिस्की यार, इसमें जो है मैथ्स करना ही पड़ेगा. आई वाज थिंकिंग if there's any quick way of doing it, but in this question you have to do it. Awesome, Bhargav, that really means a lot. I really like thermo, so it's good to know that you're able to understand it. That's a good validation of this is working. So that's awesome. This is the answer. I thought that there may be an easier way to do it, some scammy way, but I guess there was not one. इसलिए आप लोगों को थोड़ा टाइम लगा, but it's okay, don't worry about it. नीट में इतने कॉम्प्लिकेटेड मैथ्स नहीं होगा, मतलब इतना कॉम्प्लिकेटेड कैलकुलेशन नहीं होंगे. चलो ये वाला करते हैं. For the reaction, the difference in heat change at constant pressure and constant volume at 27 degrees Celsius will be constant pressure and constant volume. ये तो अभी सुना था आपने. ट्राई करो. This is one of those 30-second questions, huh? Please try it out. So now इसमें क्या करना है? You just have to identify कि constant pressure कौन सा है और constant volume कौन सा है, and then apply the right equation. Because यहाँ पे reaction हो रहा है, you have to apply the equation with this chap and not this chap. Okay, ये वाला नहीं. Let me put a very scary red color on top of this to say not this. ठीक है? Okay, Shalini and Tanu on fire, giving me the answer as B. What do the rest of you think? Do you agree with Shalini and Tanu? Delta H is constant pressure, delta U is constant volume, और equation क्या है? Delta H is delta U plus delta NGRT. Delta NG, अच्छा यहाँ पे एक ध्यान रखना पड़ेगा. अगर ध्यान नहीं रखें तो इसको गेट वेरी स्क्रीन लगे. 1/8 क्या है? इसको हटा दो, सॉलिड है, डजंट मैटर. ओके, तो डेल्टा NG कितना हो गया? डेल्टा NG होगा 1 minus 3/2, right? And yeah, oops, that's coming up right on top. Hold up. 1 minus 3/2 is negative half. Now negative half अगर आप वहां पे लिखेंगे तो negative half into R into 300 becomes 150 minus 150. But minus 150 कहां गया? Oh yeah, that's the answer. Minus 150 R. While I was giving a lecture, Dipanvita and Deepu have also given me the right answer. Tanu and Shalini. Awesome. Good job, everybody. This was as hard as the question gets in NEET. Okay, this is it. Here is another one. ये वाला actually थोड़ा और doable है. ये वाला थोड़ा time taking है. I'm not saying this is hard, but थोड़ा time taking है. एक ही question है, बस थोड़ा ध्यान से करने वाली चीज है. 1 mole of an ideal gas allowed to expand reversibly and diabatically, oh baap re, from a temperature of 27 degrees Celsius if the work done during the process is 3 kilojoule. अच्छा, इसमें एक ध्यान रखने वाली बात है, then the final temperature of the gas is CVM is here. Process is isochoric. अरे पुराना पिछला वाला क्या मीर, I'll check it out. ये वाला तो आइसोकोरिक नहीं है, इसमें तो क्लियरली बोल रहा है कि वर्क डन है। अगर आइसोकोरिक तो वर्क डन नहीं होता। तनु सेज बी। मीर आप क्या बोल रहे हैं? लेट मी जस्ट गो बैक। आइसोकोरिक, अच्छा इस ये वाला सवाल, आई डोंट थिंक द आइसोकोरिक आइडिया कम्स बिकॉज उसमें वेल आई अंडरस्टैंड मीर प्रीवियस वाले में इज इट नहीं, इधर भी तो नहीं होगा ना। थिंक अबाउट इट, वाई यू सेइंग आइसोकोरिक? डेल्टा एनजी है ना, नंबर ऑफ मोल्स बदल रहे हो गैस के, तो वॉल्यूम तो बदलेगा ही, तभी तो वर्क डन हो रहा है। उसमें भी नहीं होता, थोड़ा सोचो उसके बारे में। H is not equal to U, no? H minus U is minus 150 R. Let me just go back. But everybody else, please try this question. Screenshot एक बार try करो. Let me just explain this to Mir ताकि I'm sure that just making sure it doesn't miss this. Delta H is not equal to delta U, ना? We have to find out delta H minus delta U. और ये वैल्यू होती है। अगर ये जीरो होता तब आइसोकोरिक होता, और आइसोकोरिक तो हो नहीं सकता, क्योंकि आइसोकोरिक होता मतलब डेल्टा एन जी इक्वल टू जीरो, then maybe I could theoretically say isochoric, but that's not happening. ठीक है? All right, back to this question. Sorry about that, guys. Okay. Hey, what's up, Jeremiah? How are you trying this one? Just a couple of you saying B right now. No, only Tanu saying B. Okay. All right. Sorry that I took a bit of a detour, but Mir, I hope that's okay. Mir, I hope you've understood. Okay. So in this question, delta U is Q plus W. Well, obviously, in all questions, delta U is Q plus W. In this question, Q is equal to 0. Adiabatic, मतलब Q is equal to 0. Adiabatic क्या होती है? Boundary. अरे आज मेरे पास तो थर्मस नहीं है, but assume that this is a thermos. This is obviously not क्योंकि glass open है. अगर ये थर्मस बंद होता, थर्मस लेके आना चाहिए था. Then that's an adiabatic boundary. मतलब doesn't allow heat or mass to get transferred. Hence Q is 0. And because gas expands, the work done is negative. ये दोनों जरूरी पॉइंट थे. Okay? अब ये दोनों जरूरी पॉइंट अगर आपने ले लिए, then you make this expression. मतलब यार -3 लिखो। एक बार -3 लिख लिया, shall I explain or are you guys still trying? कोई ट्राई कर रहा है तो बता दो, I'll give you 30 more seconds to do it. It's 42, I can give you like 1-2 minutes or to do it. Anyone still trying or do you want me to explain the answer? Deepanvita, the moment I said anyone still trying, Deepanvita gives me the answer. Good job, good job. Okay. I'm not saying it's right or wrong. I want you to make an attempt and give me an answer, right? That's awesome. So, एक और छोटी चीज आपको ध्यान में रखनी है, एज इन एवरीवेयर एल्स, इसकी देखो 3 किलो जूल है, तो यू गॉट राइट -3000. ओके, एंड इस तरफ TF इज व्हाट आई डोंट नो, -300, एवरीथिंग एल्स इज डायरेक्ट. सो डेल्टा यू यहां पे कोई साइन चेंज नहीं हो रहा है, एवरीथिंग इज पॉजिटिव, बट ये कैंसिल होने के बाद -150 हो जाता है इस तरफ, राइट? सो -150 प्लस 300 which is basically 150. अगर आपके मैथ्स करने की तरह नेगेटिव टेम्परेचर आ रहा है, then we have messed up somewhere. ठीक है, बी केयरफुल. अगर ये नेगेटिव साइन नहीं डाला तो you'll get like a weird value. No, you actually will get 450 Kelvin, right? 300 plus 150, तब 450 मिल जाएगा अगर इसको प्लस लिख देते. ये ऑप्शन में है ही नहीं. Luckily 450 ऑप्शन में नहीं है. If I was a teacher, I would put 450 also in the options. खैर, Mir also saying B, Deepu also saying B, Shalini also saying B. You guys are all awesome. Good job everybody. For a gaseous reaction, A plus 3B giving 3C plus 3D. Delta U is 17 kilocal. Oh, baap re, at 27 degrees Celsius. Assuming R equal to 2 Kelvin per mole, the value of delta H for the reaction will be what? एक और सवाल ट्राई करते हैं. यहाँ पे क्या यूज करोगे? Let me tell you. Delta NGRT यूज करना है. My good friend who said you are understanding thermo, can you please try this out? Bhargav, thank you for the support. Can you try this question out? I'll help you through this. Sanchita, you as well. If you like, try it out. अगर मैं थोड़ा जल्दी जा रहा हूं, tell me to slow down, help you. Medha, what about you guys? Are you still around? Are you guys trying this question? Try karo. I'm giving you many variants of the same question, okay? Because that's all there is to thermodynamics. A little bit of questions and ये काफी doable सवाल है. डेल्टा NG क्या होगा इधर? कुछ कैंसिल करना है, कुछ कैंसिल नहीं करना है. 6 - 4 यानी कि 2 होगा डेल्टा NG, राइट? ठीक है. Mir, is that A for this one or the last one? Mir is saying A for this one. 150 तो पुराना वाला, let me just check. Hold on. अच्छा, नहीं पुराना तो B था. Mir is saying A for this one looks like. What about the rest of you? What do you guys think? ये दो चीजें मैंने बता दी. Now the only thing you got to be okay. Awesome, Mir. Thanks. You got to be careful about this, right? डेल्टा यू 17 किलो कैलोरी और आर की वैल्यू आपको लेनी है 2 एंड नॉट 8.314. ठीक है, हियर इज अ नाइस रेड मार्कर कमिंग ऑन योर स्क्रीन राइट नाउ, नॉट 8.314. कैलोरीज में इसकी यूनिट होती है 2 एंड दैट्स इट. फिर इसको ऐड करना है ना. शालिनी सेइंग सी, तनु सेइंग ए. मीर एंड तनु, कैन यू एक्सप्लेन टू मी, आपको 15 कैसे मिला? ओ, आप लोगों ने सब्ट्रैक्ट कर दिया क्या? लगता है सब्ट्रैक्ट कर दिया, लगता है सब्ट्रैक्ट कर दिया, है ना. इसमें हमको डेल्टा एच निकालना है या हाँ श्योर, इन द एंड डिवाइड बाय 1000. बट आप लोग को 15.8 मिला, बट आई फील दैट द आंसर इज सी. मेधा एंड दीपू seem to agree with what I am saying. Tanu has changed her answer. No, Tanu is still saying A. Shalini is also saying C. Dipanvita is also saying C. I think the answer is C. Tanu and Mir, मुझे लगता है आपने यहाँ पे माइनस साइन गलती से डाल दिया, इसीलिए 17 से आपने 1.2 सब्ट्रैक्ट कर लिया. 17 से 17 टू 17, सॉरी अबाउट 17 हार्ड नंबर राइट. 17 अंग्रेजी में बोलता हूँ. 17 plus 1.2 is 18.2. 17 minus 1.2 is 15.8. This is one of those questions that you got to be careful about the signs. ठीक है, ऑल राइट, ऑसम. आंसर इज 18.2. चलो कैलोरीमेट्री में और कुछ पढ़ते हैं. माइनस नहीं होगा तनु, प्लस होगा. रुको, कहां पे माइनस? माइनस क्यों किया? देखो, दिस इज द इक्वेशन राइट. डेल्टा एन जी 2 है, नॉट -2, तो देयर इज नो माइनस. ठीक है, इट्स अ प्लस. वी गुड? हाउ इट इज सी एंड नॉट ए? प्लीज ध्यान से इसको फिर से देख लेना अगर डाउट हुआ. दिस इज अ वेरी स्ट्रेट फॉरवर्ड क्वेश्चन, बट इट्स ओके. थर्मोडायनेमिक्स यही तो चीज है कि साइन अगर गलत किया तो भाई सवाल मुश्किल हो सकता है, तो ये आराम से करने वाली चीज है. ओके, थ्योरी वाले जल्दी करो, सवाल वाले स्टेप बाय स्टेप प्रोसेस लिखो, आराम से करो, आराम से करो. लेट्स लुक एट कैलोरीमेट्री, व्हिच इज जस्ट एन एक्सटेंशन ऑफ सीपीसीवी के यूज से हम लोग कैसे निकालते हैं उसको, लाइक सीपीसीवी, हाउ डू यू कैलकुलेट दैट. ओके, so this is basically a device used to measure energy transferred as heat. That's a calorimeter. Calorimetry is study of heat. It has something to do with the definition of calorie itself, right? Khair. Okay. Mir, absolutely. Plus karna tha. Good job. Okay. So, same चीज हम लोग करेंगे. We'll measure this in two different conditions, constant volume और constant pressure. Constant volume पे अगर हम लोग measure करें तो हमको internal energy change मिल जाएगा. अगर constant pressure पे करें तो you'll get delta H की value. So you will let a reaction happen and you'll use these fancy things to see अच्छा delta H और delta V की value कैसे आती है. अब why do you need this? देखिए, ये जरूरत है ताकि हम लोग उसको figure out करें कि भाई इससे गर्मी निकलेगी. Will this blow up? Do I need to make a container to sustain the heat? Do I have to provide heat for the reaction to happen? To answer all these questions, you need to know, okay, this reaction produces this much amount of heat. The number is important because in industry, we've got to design all these equipments that withstand that heat. Care. So what is delta U measurement? How do you do it? You take something that can burn, combustible, just burn in the presence of air, pure oxygen, and you seal it in something called a bomb. Yeah, this is basically your bomb right here. And this sort of setup is called a bomb calorimeter. So you've got a thermometer on top and you've got an insulated container, sealed bomb, etc., etc. Oxygen आता है. Now there's an electric spark that ignites it. That's it. Sample यहाँ पे है. That thing goes round and round and round to make thing की जो चीजें ठीक से mix हो. और the whole heat is transferred nicely through the water. And पानी यूज होता है क्योंकि पानी की heat capacity high है. तो ये यहाँ पे देखो चल रहा है, उससे हीट निकल रही है and that is measured by this rise in temperature over here. That's it. देखो यहाँ पे रेड मार्क ऊपर जा रहा है. मीर, ओके. दिव्या, हाय, व्हाट्स अप? या, आई डोंट अंडरस्टैंड कौन सा गलत किया. मीर, आई maybe I'll look at it at the end of the session. I feel that question was correct. If anybody else also feels so, I'll maybe check it again. ठीक है, but check it out. I feel वो सही किया था. Just check your math. What you wrote ऊपर is ठीक है. 17 किलो कैलोरीज वही था ना. H plus 2.2 वो सही बोला था आपने. It was a plus thing. Tanu, you're also good. Why it was C? Just आपने माइनस पिछली बार माइनस लिखा था, but you're good as to why it was plus, right? Otherwise, I'll go back and revisit it. ठीक है, cool. Now I can figure out this thing because वो सारा heat जाता है पानी में. पानी goes and raises the temperature. That's it. And using this, I know the amount of water that was there. So I know it's a what do you call it, an extensive property, right? But I know the amount of water. I know that उस पूरे system में कुछ loss होगा, कुछ होगा, but that whole system I can assign a C value to it. Okay. Now that C value is this right here, molar heat capacity of the calorimeter at constant volume. Now once I have that, then I can use this expression to get the heat of that reaction in a closed vessel. That's it. Okay. Now if I want to do a similar thing but at constant pressure, then it's important that I don't have gases coming out. Okay. This is important in this measurement. So this is just a cup, right? It's called a coffee cup calorimeter. In this, say for theory, I could just put KOH in water and इसी से हमको गर्मी निकलेगी, right? Sometimes this happens. You put KOH inside water and बहुत गर्मी निकलती है. उसको measure करने के लिए I use this sort of a setup, open to the air, which means कि delta P is 0, hence this is a delta H measurement. Anyway, so QP is delta H, and for a particular reaction, which is what we're getting to, thermochemistry, that's up next in next session. Or this is the second part of thermodynamics. There are three parts to it, right? First part was where we did delta U. Second part was this, and the third, delta U and delta H was first part. Thermochemistry extensively, second part, and third part is the entropy wala part, entropy delta G, which will be a little bit small. I still haven't gotten a response from Tanu or Mir on that last question, so I'm assuming you guys are good with it. So we'll move on. Okay, sweet. So मैंने शुरुआत में आपसे पूछा था if you know what exothermic reaction was, all of you are like yes हमको मालूम है, तो good, I'm not going to spend too much time on it. Exothermic मतलब गर्मी रिलीज करना, endothermic मतलब गर्मी अंदर आना, गर्मी आने की heat. Okay. Now this is interesting. There are some times that students forget that when I make a reaction happen और वो reaction गर्म हो जाता है, mixture, that must be exothermic. So, but अगर reaction ठंडा हो जाए, and that is endothermic, that is something the students are like, what? How is that even possible, bro? And there are substances, look it up, okay? And ये lower grade में पढ़ा है, endothermic, exothermic में. If you mix them, the reaction mixture actually gets cold. So, पानी से गर्मी लेके reaction proceeds. Look it up, it's very fascinating, but it's obvious. If you're mixing two reactants and the reaction is happening और गर्मी निकल रही है, if you're calling that exothermic, अगर दूसरा reaction है जहाँ पे गर्मी consume होगी, which means gets cold, must be endothermic. Think about it. इस पे सवाल आ चुके हैं एक दो बार. Okay. Anyway, so if the final energy of the reactants is low, of the products, this is product, right, is lower than that of the reactants, that means that heat is released. Energy is, the same. Initial and final energy are the same. Delta E is 0, delta E, delta U, whatever you want to call it. Heat can be transferred, but it cannot be energy neither created or destroyed. So अगर ये कम हो रहा है, तो कहीं ना कहीं तो जाना चाहिए. It goes in the form of heat. Such reactions called exothermic reactions. This right now the reaction coordinate. मतलब कि यहाँ पे सिर्फ reactants है, यहाँ पे सिर्फ products है. Similarly, if the products are at a higher energy than the reactants, that means कि they consumed energy, right? So this is an endothermic reaction. इस ग्राफ को आप लोग याद रखिए. 12th grade में you will see more funky things happening with it. Okay, when you do kinetics, then इसके ऊपर एक और बन जाएगा. All right. Any doubts so far? Are we good? Awfully silent on the chat. 1 घंटे होने को आया है. I am aware. Just a couple of quick questions and we'll get done soon. Okay. So now why are we doing this whole enthalpy change wala business? Thanks Medha for the feedback. Why are we doing all this? Because देखो, ये करने से हम लोग प्रेडिक्ट कर सकते हैं कि अच्छा इस रिएक्शन में हुआ, उस रिएक्शन में हुआ, तो तीसरा रिएक्शन जो मुझे कोई आइडिया नहीं है कि उसको होने से क्या होगा, I can kind of deduce what will happen there. That's the main idea. Theoretically, if I know the heat change of reaction 1, reaction 2, जो hypothetical reaction 3 है, उसका I can figure out, oh, maybe it will be close to this, and exactly this, hence I can design some sort of a reaction chamber for this to happen. ठीक है? Okay. Thanks, Shalini. Here's a quick question. 1 mole of an ideal gas undergoes a change of state, blah, blah, blah. What's the change in enthalpy? Straightforward question. P1 V1 to P2 V2 and delta U. But what expression will you use here? This is a 30-second question. What's the starting point? कौन सा equation use करोगे? That is what we have to figure out. Try करिए. Try करिए. You guys trying this? लेट मी राइट दैट डाउन। ये इनिशियल स्टेट है, ये फाइनल स्टेट है। हे श्रुति, व्हाट्सअप, हाय हाय हाय। सवाल ट्राई करिए। यू गॉट इनिशियल एंड फाइनल स्टेट्स ऑफ प्रेशर, वॉल्यूम, एंड आई हैव गिवन यू डेल्टा यू। आई एम आस्क्ड टू फाइंड आउट डेल्टा एच। एक्सप्रेशन तो यहीं पे है ना, डेल्टा एच इज डेल्टा यू प्लस डेल्टा पीवी, डेल्टा ऑफ पीवी बोथ। तो this means P2 V2 minus P1 V1. So this is final minus initial. Okay. So 30 plus 8. मतलब 38 and not 22. Mir, good job. Proud of you. Any doubts? This is the right answer. Yeah. And not 22. Shruti, thank you. Excellent job. Excellent job. Tanu also saying B. Let me go back to the question. Thank you. Good job. Good job. Absolutely. Easy se sawal, but this was the extent of it. Okay. So what is thermochemistry? I gave you the word very loosely. We're trying to figure out a theoretical way of finding out the heat change of a reaction. Right? We can perform some experiments. Some experiments are like a little scary. So before you perform them, you figure out, boss, isme kya hone wala hai? Let's find out before we do it. Okay. So, and plus there are hundreds of reactions. You can't go on performing all of them to figure out. So you do some of them, you know its value, and then you're like, acha, ye wala naye wale ka maybe something like this. That's the general idea. So what are the factors you're going to keep in mind? Physical state. Is it solid, liquid, or gas? Allotropic forms. Okay, wow. Allotropic form matlab P4, S8, etc., etc. Right? This is phosphorus, this is sulfur. Allotrope hote hain. Or carbon as graphite. That's what the standard state is, etc. Amount of reactants, मतलब number of moles, and temperature. ये चीजें हम लोग को we have to keep in mind. Okay, all of these things will change the value of delta H. क्यों? Because delta H is an extensive property, and it is not path dependent, which is a state function. Okay, sweet. So the standard state I just told you is defined as something that okay at 1 bar, मतलब एक bar, not 1 atmosphere, at 1 bar. प्योर फॉर्म मतलब कि ऑक्सीजन का प्योर फॉर्म क्या होगा? गैस. एंड लेट्स टॉक अबाउट 25 डिग्री सेल्सियस फॉर ऑक्सीजन. बट से फॉर आयन आई टॉक अबाउट 500 केल्विन. दिस इज इट्स प्योर फॉर्म इज एन आयन रॉड, राइट? इस पे 298 केल्विन, लेट्स से एट 1 बार. दीज आर स्टैंडर्ड फॉर्म्स एंड इसमें लिक्विड है, सॉलिड है, गैस है. दैट्स व्हाट यू विल फिगर आउट. ठीक है. हे थैंक्स श्रुति. हे कन्हू, आई कांट फॉलो दैट लैंग्वेज. आई यूजुअली I can't read, but it looks like a mix of Tamil and Malayalam and Telugu. Or I think it is symbols, bro. You're messing with me, Kanu. Great, no, Shruti. Great. Are you able to follow what's going on? If you have any doubts, please ask me. Just a couple of more minutes to go. We'll wrap this up. छोटा सा एक idea है, right? We'll look at its application in the next session, but ये बहुत जरूरी है. देखो, अगर मैंने एक इक्वेशन ली और उसकी एंथैल्पी चेंज ये है. एंथैल्पी चेंज मतलब डेल्टा एच ऑफ दैट रिएक्शन. आई हैव यूज्ड कैलोरीमेट्री कुछ करके आई हैव गॉट दिस वैल्यू. देन इफ आई टेक से इंस्टेड ऑफ दिस मच, अगर मैं इस रिएक्शन को रिवर्स कर दूं, वो रिएक्शन रिवर्स क्यों? थियोरेटिकली बोल रहा हूं भाई, सुन लो. रिएक्शन रिवर्स किया. अब कैसे किया भगवान जाने, बट किया. मैथमेटिकली मैंने कर दिया. तो अगर इस रिएक्शन में हीट रिलीज हुई तो उल्टे रिएक्शन में हीट कंज्यूम या अब्सॉर्ब होगी. अगर हीट अब्सॉर्ब होगी उल्टे रिएक्शन में, मतलब ये प्लस हो जाएगा. एनी डाउट्स? एनी डाउट सो फार? इट मेक्स सेंस, राइट? एक डायरेक्शन में किया तो हीट रिलीज हुई, वही हीट अगर मैंने वापस रिएक्शन में डाल दी तो इस तरफ चला जाएगा. अब आई नो इट इज नॉट पॉसिबल फिजिकली, बट मैं बोल रहा हूं थियोरेटिकली सोच लो, पॉसिबल है. जस्ट लुक एट दिस एज अ मैथ्स इक्वेशन, नथिंग एल्स, जस्ट अ मैथ्स इक्वेशन. ठीक है. मैं हूं ऑफलाइन सेंटर से, मतलब मैं घर पे बैठा हूं, इफ यू कैन कॉल इट ऑफलाइन सेंटर. मेरे घर के पास है एक्चुअली, आकाश सेंटर राइट हियर ऑन जेपी नगर. एनीवे, रिवर्स करने से हो गया. ऑल्सो इफ आई चेंज द नंबर ऑफ मोल्स, यानी कि मैंने एक मोल में आधा मोल लिया तो एनर्जी आधी हो जाएगी. दिस इज ऑब्वियस ना. दिस इज, ये तो बहुत स्ट्रेट फॉरवर्ड है. अगर मैंने 1 किलोग्राम लिया, उसका आधा लिया तो कम होगा ना. आप अगर तेल बना लेते हो खाने के लिए, थोड़ा तेल लो तो जल्दी गर्म हो जाता है, ज्यादा तेल लो तो ज्यादा टाइम लगता है. सेम चीज है. ठीक है. Oh, okay, cool, sure. There's a link, Yash, in the description box. there's a link to the Aakash thing itself. You can just scroll down the description box and you can click on that. You can figure that out. All the best with that. Okay, good to know, Deepanvita. Exactly 1 hour. And we are done. If you multiply with 2, मतलब 1 किलो में 2 किलो ले लो तो ज्यादा गर्मी निकलेगी. Make sense, right? बहुत theoretical ideas. इसको हम लोग अप्लाई करेंगे next time. Here are a couple of homework questions. इस बार please कर लेना homework. इस बार we are doing a session at 7 p.m. at the slot that you guys wanted. Please do this homework. This is the first question. I'll go to number 1 over here. Take screenshots or come back and do it. This is the second one. ठीक है? Most welcome, Yash. Just look at the description box. I think the third or fourth link is just that. I think first वाला subscription है, second is Aakash BYJU'S app. I think third or fourth link वहीं पे कि you can, अगर कोई queries है तो उसको fill कर दो. Okay, what did we do so far? हमने शुरुआत की इससे delta Ng मतलब reaction actually होता है उसकी. Then we said there's something called specific heat capacity, boss. Specific मतलब कि per unit mass. Okay. Then हमने बोला molar और ये भी होता है, मतलब मोलर हीट कैपेसिटी, कांस्टेंट वॉल्यूम, कांस्टेंट प्रेशर, दो अलग अलग पार्ट्स के लिए हमने डिराइव किया, सीपी सीवी की रिलेशनशिप बनाई आर के साथ. देन वी सेड कि अरे कैलोरीमेट्री भाई, उससे हम लोग निकालते हैं, ठीक है, ये सीपी सीवी लेके एक रिएक्शन में कितनी एनर्जी होती है वो निकाल सकते हैं. एंड दैट वाज द मोस्ट इंपॉर्टेंट थिंग फॉर दिस चैप्टर. द नेक्स्ट पार्ट ऑफ दिस चैप्टर व्हिच इज कि यू गेट डेल्टा यू इज एनसीवी डेल्टा टी, डेल्टा एच इज एनसीपी डेल्टा टी, एंड एक्सोथर्मिक और एंडोथर्मिक रिएक्शंस की डेफिनेशंस. एंड लास्टली we finished it up with the idea of what is the standard state and idea of reversing, multiplying reactions and all of that. ठीक है? That's all for today. I know लंबी क्लास हो गई, 1 घंटे की. We'll meet again at 8:45. जल्दी से खाना खा लो, अगर मेट्रोलॉजी देखना है तो आ जाएंगे, वहां पे मिलेंगे. ठीक है? All right. Safia, good. Thank you for being one of them. Well, a lot of you guys watch these things after the session gets done, right? Which is great. As जैसा भी आपको ठीक लगे, however you guys want to consume it. All right. Thank you so much for joining in. I'll see you guys at 8:45 for the metallurgy session. And thanks. Do the homework questions. Bye.